Alright, here on the board are some equations that we should solve. Before we delve into solving those equations, we are going to look at something. I remember I said in the last lesson that, or previously, that an algebraic equation contains, there are different types of algebraic equations like linear equation, the quadratic, the cubic. Now let's look at the difference between those three primarily before we can look at the other ones. A linear equation has this form, okay? Ax plus b equals anything, let's say c. Okay, that's the form of a linear equation. What this is not to mean that a linear equation is always like this. It's the form in which it takes. Now, what are the characteristics of this equation that I've written here? Now, you can see that the power of x here is 1. Okay, and then there is a coefficient of x, which is the coefficient must not be equal to 0. Okay, a not equal to 0. And then there is a constant. Okay, even though this particular constant, this constant can be 0. Alright, and then there is another constant here. Alright, so this is the form, this is the linear equation form. Now, if it was a quadratic equation, you're going to get something like this: ax squared plus bx plus c equals, let me make this equals 0. Alright, so this is the form of a quadratic equation. Of course, in this quadratic equation, a, that's the coefficient of x squared, cannot be equal to 0. Must not be equal to 0. If it is equal to 0, it returns back to a linear equation, because everything here will become 0. You'll be left with bx plus c. Okay, so this is for a cubic equation. A cubic equation will have this form: x cubed plus bx squared plus cx plus d equals 0. Alright, so these are the forms of those different equations. But for instance, talking about linear equation, when we say a linear equation has this form, what it means is that we are going to have, let's say, 2x plus 3 equals 0, or 4x plus 5 equals 7. You know, stuff like this. These are the things that tells us whether an equation is linear or a quadratic equation. Each of these equations, linear, quadratic equation, cubic equation, they have their approaches for solving them. Alright, and that's what we want to actually look at right now. So the examples I have here are all examples on linear equations. They are all linear equations. Why are they linear equations? Because the variable, which is x, is raised to the power of 1. It's just 1. There is no number on the variable apart from, there is no number on the variable as a power. So we can just say that we have x raised to the power of 1, you know, and same goes all through. Alright, that's it. So we're done with that. So let's just solve this. Let's solve this problem now. Alright, now starting with the first one. Now if you have seen my video on the previous video where I talked about simple algebraic equations, you should be able to deal with this, okay, because this is quite simple. I told us that whenever you have an equation, you balance it. In order for you to solve it, you have to balance it. And this question says solve the following equations. What does it mean when they say solve the following equations? It is solve really actually means that you should find the value of the unknown. That's the value of the variable. This is called a variable. All the x here are called variables. Alright, so when they say solve the following equation, you are simply being asked to find the value of the unknown. Alright, so how do we now find x from here where we have x plus 5 equals to 6? Simply what this equation means is what number x is standing for any number that can be added to 5 to give us 6. So now how do we now solve this? Solve this. What we do is, because there is 5 added to x, okay, so we need to remove the 5 to get to know what x is. Alright, so in order to remove the 5, we are going to get x plus 5 minus 5. We are removing the 5, and then on this other side it is going to be 6 minus 5, because the rule in solving equation is that whatever you do to the left hand side, this is your left hand side of the equation, this is your right hand side. Whatever you do to the left hand side, you must do to the right hand side. That's what we call balancing method. Okay, that's called balancing. Alright, now having said that, so plus 5 minus 5 is actually 0, right? So that means everything here is gone. We are left with x alone. And then on this other side, you have 6 minus 5. 6 minus 5 is simply 1. Alright, now before now, if you had guessed that if you add 1 to 5, you get 6, yeah, you were correct. But this is how to actually show how the answer comes about. Okay, let's move to the next one, where we have 2x minus 5 equals 7. 2x minus 5 equals 7. Now, what are we going to have to do? Now, you see, we have 2x minus 5 equals 7. So, for us to get to find what x is, we have to remove whatever is added or subtracted from it. Now, how do we remove minus 5? Because this is like 2x and 5 was removed and we got 7. So what will happen if we add the 5 back? So this will now become, this equation will be 2x minus 5. Because we have minus, we are going to do the opposite. Plus 5 equals 7. Remember, whatever we did here, we are going to do here. So is this going to be 7 plus 5? So we are left with 2x minus 5 plus 5 equals 7 plus 5. Now, what do we do further? So this will become 2x. Minus 5 plus 5 is 0. Okay? You had nothing. Okay, let's say you are owing 5, okay, to Mr. A, and Mr. B gives you 5. So what does that mean? This is what you owe. This is what you're giving. So you're going to use this and pay this off, right? So you'll be left with nothing. Okay, so 2x will be equal to 7 plus 5, which is what? 12. So with this now, what do we further do to remove the 2 here in order for us to get x? Remember, our target is to get x. Now, since x is 2 is connected to x by multiplication, so we do the opposite of multiplication. And what's that? The inverse of multiplication, which is what? Division. So we divide here by 2 and divide here by 2. Okay, so when we divide both sides by 2, this 2 will take care of those 2. Like 2 divided by 2 will be 1, 2 divided by 2 is 1. Alright, so you're left with x equals 12 divided by 2, which is 6. So your answer is 6. You see that? So we can actually check this if this is actually correct. Remember, they said 2x minus 5 equals 7. That means if we put 6, because x is equal to 6, so if we put 6 in the place of x, that means, and then multiply it by 2 and subtract 5, we are going to get 7. Let's check that out. So you see, this is going to be 2x minus 5 equals 7. Let's check. So we have 2 times 6 minus 5. So 2 times 6 is what? 12. 12 minus 5 is what? 7. So that's correct. Okay, let's move on to the next one. Let's move on to the very next one here, where we have 5x plus 3 into the bracket of x plus 5 equals 7x. Now this is a little bit advanced now, but it's just the same methodology, only that in this case the right hand side is looking a little bit complex. So all we have to do is to simplify the right hand side first of all. Okay, so Well, how do we do that? We are going to have this to become 5x plus, we use, remember here is a bracket, right? So whenever we have a number outside the bracket, what that is telling us is that the number outside the bracket can be used to multiply everything inside the bracket. So this will become 5x plus 3 times x, which is 3x, and 3 times 5, that's this times this, and this times this. 3 times x gives us 3x, 3 times 5 gives us 15, equals 7x. Alright, so now you can see that we have 5x plus 3x plus 15 equals 7x. Now the question is, what do we do? What do we do in this case? In this case now, we are going to have to collect all the like terms. Okay, we collect like terms, right? We collect like terms. Now, what do we mean by collecting like terms? What that means is that all the variable terms. What I mean by variable terms are I said x is a variable, right? X is a variable, x is a variable. So all the terms containing the variables is what we call the variable terms. All the variable terms will be on one side, and this other term that does not contain the variable is called a constant term. Okay, so it has to be on one side too of the equation. So that's the arrangement. So first of all, before we do that, before we collect like terms, what we're going to do, let's simplify here. 5x plus 3x is going to be 8x, right? 5x plus 3x is going to be 8x. So plus 15 equals 7x. So now what do we do? Like I said, we make all the variable terms to be together. So all the variable terms to be together means this guy, is either this guy will come and meet this guy here, right? Or this one will go and meet this guy here. Alright, so all we do, and then this guy will move in the other direction depending on how this guy move. Okay, now let's say I'm going to take this guy away from here to meet this guy. So this is going to be 15 left equals 7x. Then this 8x coming over to meet this guy, because it's going to, like as it is now, it is a positive number. Okay, it's a positive number. Any number just standing on its own, okay, without a sign attached, is a positive number. Now, so when it moves across the equality sign to meet this guy, it will become a negative number. Okay, to become minus 8x. Now, so this will now become 15 equals 7x minus 8x is going to give us minus 1x. Okay, because actually 8 minus 7 is 1, right? Yeah, 8x minus 7x is supposed to be 1. But now that it's we are removing a bigger number from a smaller number, it means we are going to get a deficit of 1x. That's why it is negative. Okay, now normally we don't have to write this one to it. Just negative x is enough. Okay, just this is enough. This is enough to tell us that this is minus 1x. Okay, so with this said, now remember we are looking for x, alright, not minus 1x. So if we are looking for x, so what do we do to get x alone? We divide both sides by minus 1. Okay, by minus 1. So when we do that, we are going to get 15 over minus 1 equals minus x over minus 1. Okay, so this minus divides minus to become positive, and we are going to be left with 15 divided by minus 1 is minus 15 equals here x. Alright, so that's what we have. So that means that x here is actually equal to minus 15. You can write it this way. Okay, so that's it for this guy. So we are going to also look at the other example, the last one but not the least. Okay, so let's look at that guy. I believe you should be able to try and attempt it already. You should know what to start with, how to start, and how to progress. Now, so this is 11x minus 4 into the bracket of 2x plus 4, right? Yeah, plus 17 equals x minus 31. Excuse me. So that's what we have here. Alright. So how do we now proceed to solve this? Like I said, whenever you have one side of the equation looking like say complex, all you just need to do is to simplify it. Okay, so simplify it. So this will now become 11x. In the process of simplification, we have a need to clear a bracket here. So we are going to use minus 4, not just 4, minus 4 outside the bracket to multiply whatever is inside the bracket. So minus 4 times 2x is going to be minus 8x. Then minus 4 times plus 4 is going to actually be minus 16. Minus times plus is minus. Minus times plus is what? Minus. So that's why we have minus 4 times plus 2x here. This is plus 2x. A number standing on its own is positive. Okay, so with this said, then this is going to be plus 17 up here equals x minus 31. Alright, so now with what we have here, so this is going to simply be 11x minus 8x is 3x. Minus 16 plus 17 is going to be plus 1. Okay, minus 16 plus 17 is going to be equal to plus 1. I'm going to do a video on directed numbers so that you can actually know how those things come about. You just look out for my video on directed numbers to understand how this works. Okay, so this is going to be equal to x minus 31. X minus 31. Alright, so now at this point, you see, we have simplified this part and simplified this part. So what we are going to do next is do what? Make sure that all the variable terms are on one side and the constant terms are on the other side. This is a variable term. If you remember, this is a variable term. It contains the unknown, the variable. Alright, so how do we make them to be on one side? We move them across the equality sign. So I'm going to move this guy to this part to meet this guy. So this is going to become, that's the same thing like saying collect like terms. Okay, like saying collect like terms. So I'll move this guy to meet this guy. So this will become 3x. When this guy, which is positive, this x here, which is positive, moves across the equality sign, is going to be negative x, right? Then equals, this guy moves. This guy is positive here. It moves to meet this guy to become, remember what we have here is minus 31. So 1 coming to meet it to become minus 1. It's positive. When it comes over, it becomes negative. Alright, so 3x minus x will give us what? 2x equals minus 31 minus 31 is simply minus 32. So it's just like saying minus 31 plus minus 1. Minus 31 plus minus 1. So when you add the two minuses together, it becomes minus 32. So remember, here we are looking for what? X. So if we are looking for x, what do we do at this point? We actually, there is a number standing close to x, and that number is standing close to x by virtue of multiplication. So we do the inverse of the multiplication, which is division. So this will now become 2x divided by 2. Okay, we divide both sides by 2. Remember, whatever we do to the left hand side, we must do to the right hand side. So this becomes this. So 2 will cancel 2 here. I will be left with x equals minus 32 over 2 is minus 16. Alright, so that's the solution for this. So that's it for these examples. Thank you.